Hello and good morning to everyone. This is bright and early in this time of day, especially here in Brussels. Welcome everyone to the eArchiving Geospatial Digital Records Preservation Conference Day 2. I hope you all had a very good day 1. We heard a lot of speakers, we heard from a lot of people. Let's keep that energy up, let's keep it going. My name is Pavel Stech, and I am the onboarding manager for eArchiving. And I will be the semi-moderator today, just the moderator for the morning session primarily. We are all happy that you have registered for day 2, and I hope we all hope you find it informative. Before we get started, I would like to reiterate a couple of housekeeping points. These are the same points as yesterday. All participants' microphones are muted upon entry, and please keep yourself muted so that we can hear the speakers clearly. Unless you are participating, we advise you to keep your camera off. This does preserve the quality of the connection, and especially for privacy reasons. If you have any questions, please be advised to use the chat function. We are controlling it. We are looking through it. And just like yesterday, your questions will get answered. Also, if you have a specific question for a specific speaker, especially in our
maybe other podcasts and other media influencers will start using it all massive audiences.
Can you please keep yourself muted?
Facebook less powerful tool. I know that I would love to see maxed audiences.
Thank you. If you have any questions directed to any of these other speakers, please add them in the chat function and they will be answered accordingly. Finally, this session is recorded, but no personal information will be will not be shown. And so with that out of the way, let us begin our Geospatial Conference Day 2. And so to our good morning welcome, we have Radoslav Jakub from HaDEA. Jakub, the floor is yours.
So good morning to everyone and welcome to the second day of eArchiving Geospatial Digital Records Preservation Conference. I hope that you have enjoyed the first day of the conference, at least as I did. I am not working directly with the data preservation records, but as any user or future stakeholder, I appreciated how clearly the needs, relevance for digital records preservation in future, and also now, of course, including the available solutions were presented yesterday by the speakers and then followed by the questions. As it was said, my name is Radoslav Jakub and I work for Health and Digital Executive Agency, in short HaDEA. As you can see from the name of agency, HaDEA will be supporting the progress in Europe in health domain, and this includes also food safety, and in digital, industrial, and even space domain by providing funding to research and application of its results into practice. This is very short information about HaDEA, therefore later on I will insert a link to our webpage in the chat. I suppose that you might be asking why I am here today with you. I work as program manager in HaDEA in the unit that will implement part of the Digital Europe program. And recently, as of 1st April, I was assigned to eArch 3 project that builds eArchiving building block. This project was transferred to HaDEA from the European Commission. And one more clarification, I am not a policy officer for eArchiving building block. This is still DigiConnect, and in person it is Fulgencio who opened yesterday the conference, and Adelina who will be closing it at the end today. So basically HaDEA, and that's also me, follows the policy instructions of the parent DG, Connect, to implement the archiving policy. This means organizing calls for grants and evaluation of proposals, contractual procedures, monitoring of the project implementation, assessing the achievements of the results, also, of course, with the experts and technical support, sometimes also from the European Commission. We execute the payments, and what is also equally important, we provide the feedback to the policy owners. So back to the Commission. I am thankful, real thankful to the organizers to have this opportunity to be today with you and to listen and to absorb as much as possible the technical side of geospatial data preservation. From yesterday, I would like to highlight that eArchiving building block helps with adopting digital preservation strategies, including their application in practice. It provides common specifications, information packages, sample software for eArchiving, migrating and reuse of data, trainings, webinars for stakeholders, and dissemination and communication about this building block itself. So please do not hesitate to contact the help desk for eArchiving. Today, the presentations and discussions will focus on interoperability, standard specifications and requirements for the geospatial data preservation. And this is the technical interoperability, which we hope, and I hope as well, will be soon turned out into interoperable Europe. And this will be supported by the digital, normally all these interoperability systems and also for the public administration should be supported in future within the digital decade and digital Europe program. And with this, I pass the word to Gregor, who is much better placed for introducing the upcoming agenda and topics to be presented. So stay tuned and enjoy the conference.
Thank you, Rado. Do you hear me and see me? Is everything connected?
Yes, we can hear you.
Yes.
Okay.
Yes, we can.
Okay. Excellent. I mean, according to yesterday's difficulties, I just like to check first. So, yes, we have a morning session today instead of a afternoon session like we did yesterday. And yesterday we started with some existing practices, what people are doing, and we also showed with some interesting presentations how this geospatial data can be reused in the future for decision making, for not just in governments like in the statistical office, but also in businesses like it was presented through the MicroStrategy example. Today, we are going to focus on the points that were actually pointed out yesterday, that for the data to be very useful in the business context, it needs to be accessible fast. And the difficulties for accessibility are commonly different data models, different formats, and so on. And that is why standards were invented. And in our case, we also have a lot of standards, and a lot of standards are being developed. So today's session in the morning will basically introduce some best practices on these fields. And the last two presentations will be on the specifications that we are developing in the eArch 3 project within the eArchiving building block to enable Europe to preserve geospatial data in an interoperable way, so it could be accessible in an interoperable way and support the digital economy. And for the conclusion, we will conclude with the roundtable with 4 speakers, where we will discuss how the new technologies are actually impacting preservation of geospatial data. Because when we started preserving the geospatial data, we started with basic data sets in the vector and raster formats. However, today the technology is becoming more and more complex and versatile, and we see that we need to think about preserving different kinds of data. One spatial data set was presented yesterday in the form of building information systems, and we also need to think about how to develop the specifications, the eArchiving building block to support this type of data. And this is what I think that the debate in the roundtable will bring us. So this is my introduction to inform you about the program and what's the idea. And now I would like to invite Anja, as the member of the Slovenian National Archive, to say some words.
Thank you, Gregor. Good morning, everyone, and welcome on behalf of the National Archives of Slovenia. As Gregor and Rado already discussed and told us, we are in for another day of interesting presentations and discussions. So without wasting any time, I'm placing the steering wheel in the hands of the moderator of our first session, Rink Kruk from National Geographic Institute. Rink, hi, and The floor is yours.
Hello. Thank you, Anja. Thank you, Gregor. Thank you, everyone. Good morning. I'm very happy to see so many participants again at this second part of the wonderful conference on eArchiving of geospatial data. Before we start with the session, I would like to explain the housekeeping rules of this morning, which is always necessary to remind everybody of. So I would like to ask you to please keep your microphone muted and camera off, unless you are speaking or invited to speak. Each speaker will have maximum 25 minutes for the presentation. If you have questions, then please place them in the chat to everyone or to us, so the questions can be answered during the question and answering session at the end of each presentation. You may also post a question then in person using microphone and camera. Yeah, so you're well invited. Then please raise your hand. So now I would like to start with the kickoff. In concurrence with the internationally recognized principle of making data fair, which means findable, accessible, interoperable, and reusable, we will pay this morning attention to the I and R of fair this very first half of the morning. We will listen to a set of presentations on ensuring access through interoperability and let me see, and dissemination practices. The presentations will be kicked off by Jaana, is the grants manager at the National Geoscience Data Center in the UK, which is hosted by the British Geological Survey in Nottingham. And she leads a team of data managers providing a full service to geoscience researchers funded by the Natural Environment Research Council, which is very known council in the UK, advising them on data policy and best practice in data management and long-term preservation. She is also developing a digital preservation program for the British Geological Survey and maintains a list of preferred geoscience and geospatial file formats to support researchers transferring their data to the NGDC for long-term storage. Geological data already has a very long history, or records long history, and so Jaana, she takes care that this very long geological history is well preserved and accessible on the long run. Jaana, can I give you the floor? Please.
Thank you.
Take the floor.
And just in case there are technological hiccups, I'm going to stop my video and share my slides.
Yep, thank you very much.
Can you see the slides?
Yes, we can.
Excellent. So first of all, thank you for all the previous talks. I've been really interested in hearing all the experience at this conference. It's eArchiving is a new concept to me, and the first conference as well. I'm not an archivist, I'm a senior data manager, but I work in research data management, digital preservation, and corporate records. So this is part of what I do. What I'll do today, I'm going to share some everyday challenges and experiences in geospatial data within the UK public sector. The first half of my talk will concentrate on our data center data archives and the development of our new digital preservation program. And in the second half, I will share some examples and experiences of my geospatial research colleagues. So let's see if the works. Here we go. So first, a little lesson in acronyms, which are very popular in our public sector. So we are really called the NGDC, or the National Geoscience Data Center, and we are hosted by the British Geological Survey since, well, a survey has been there since 1837. The data center is much newer than that. But the survey is the UK's premier provider of objective and authoritative geoscience data. And the NGDC is one of 5 environmental data centers under the UK Research and Innovation, which in turn looks after the Natural Environment Research Council. So the NGDC is part of an EDS, which is the Environmental Data Service. And the EDS provide access to all scientific information and data, which is funded by NERC. The other data centers you can see on the site, but today I concentrate on the geoscience and subsurface data. The others are atmospheric, space physics, terrestrial, freshwater, polar data, and the marine oceanography data. Our data archives. So we collect and preserve geoscientific data and make them available in the long term for a great group of stakeholders and communities. At the moment, we have about 1.78 petabytes of digital data on both the storage area network at different sites and on tape archive. We are an official place of deposit under the UK National Archive. We have a Core Trust Seal certification, and we are expected to make all this data available under the UK Open Government License to all users, even for commercial use. The data types we hold cover a big range of geological disciplines, and of course they are created in a large number of digital file formats. And if you want to have a better look at what the data covers, you can have a look on the website where there's an Explore Our Data section. We also have a lot of analog data. For example, 250 kilometers of boreholes, 350 kilometers of offshore drill core, 4.5 million samples. And the age of our data ranges from geological timescales to near real-time sensor data streams. Some examples of the data types. So of course today we are talking more about geospatial. A lot of this data comes under that, but not necessarily so. And anything to do with what the geoscience under your feet, from hydrogeology to geochemistry and physics, engineering, mining, natural hazards, geomagnetism. We have another data center in Edinburgh looking after geomagnetic data. Anything from rocks, sediments, energy, oil and gas is a big industry, of course, to climate change and 3D modeling. So to look after this data, we have a lot of different experts because not one person can manage all of these data types. And we have about 400 different data sets in our care, and they are managed by the NGDC. We also have a wide range of licensed geospatial data sets, and they vary from the geological data family to offshore data, ground stability data sets, and 3D models. And here are just some examples. Again, you can have a look on the website if you want to investigate a bit more. The geohazards data sets, which are a main example of our geospatial licensed data, they are mostly on the scale of 1 to 50,000. GIS polygon data. Some are open access, others available by request or by license. So then there's coastal vulnerability. On a big island, some of our coasts are crumbling into the sea, so that's a big industry for the UK. Groundwater flooding equally. Landslides, there's landslides all over the coast, so that's important. Also mining hazards, there's loads of old mining areas which are no longer actively being used, so we have maps on those, and also radon potential, which even general public have access to. And many of these data sets which you can access on the website come with user guides as well. And for example, there's technical information about the data sets with the data, so you have scales, field descriptions, how the data sets were created, their history, coverage, data formats, and also limitations. Now, with all these data sets in our care, we have a lot of drivers that have an impact on how we work. So we are the custodian of the nation's geoscience and subsurface data archives, even though we are a data center, not an archive as such. A lot of the data are generated by the BGS science activities. We also get statutory, commercial and voluntary geoscience data donations from different companies, organizations and even individuals. And my day job is managing data generated by a NERC-funded geoscience grants. So NERC fund projects every year worth millions of pounds, usually at universities, but also some global projects. So I liaise with the grant holders about best practice and get a copy of the data in at the end of the project. The UKRI data policy states that we have to ensure access to those data, usually at least 10 years, sometimes 20 years after the research project has completed. And we have a reputation as being a reliable and centralized open data access point. People know we hold this data, they come to us, even if they don't know what specific data they come after, but they come and ask, and we usually find something for them to work on. And all our data is meant to be there for all data reuse purposes and innovation purposes, and the I in UKRI, research and innovation. I took an interest in preserving this data some years ago when I did a master's dissertation, where I explored the requirements for digital preservation at the data center. And one of the main findings was that it's not the 5 or 10 years in the digital world that we need to be concerned about. Geoscience data is usually requires permanent retention, which we also have to do under the National Archives place of deposit contract. So we started working on from the beginning. So I wrote a digital preservation policy in 2017, and then to justify the need to do this as well as the research and data management, wrote a business case 2018, developed it into a strategy a year later. And COVID interfered a little bit there, so we had a gap year whilst trying to manage the work, but we now have a small digital preservation team in place and can start doing this work in earnest. A lot of our data are semi-current records, so it's not archives where you put things away and they never get touched. Researchers and commercial organizations and other parties, academics, use most of our data more or less frequently. And at the moment, we are working to bridge the gap in understanding between our data center staff, the researchers, data specialists, data generators, depositors, reusers, digital preservation organizations like the Digital Preservation Coalition, and of course talking here to you all and hearing your interesting talks is part of our work. So we, as part of our digital preservation strategy, we wrote down an aim, which is to maintain the long-term reusability and accessibility of authentic born digital and digitized geoscience and geospatial data objects as long as required, as evidence of the current UK PLC scientific and research record. So that's a big aim. Part of what I told you before was the Core Trust seal certification. So at first that was an aim, but now it's become a driver because we are just in the middle of renewing that certification. And as you are aware, it has a lot of requirements which cover the whole life cycle and how the data center works, which means that all our processes and workflows and our best practice in both RDM and digital preservation are now under constant review. And both data center staff and researchers are exploring standards for adoption. So my colleagues work with the Open Geospatial Consortium, for example. A small part of the preservation program is we are maintaining a preferred file formats list to advise data producers who transfer their data to the data center, and that's accessible on the website. The first version was online in 2017, and we updated it last year. And that included this time a lot of conversations between the researchers and the data center staff to explore the requirements for frequently captured and generated data types. So this is a starting point for us, and I've heard excellent talks about standards and other ways of doing this, which I'm sure to implement later on. But at this time, we looked at the Library of Congress recommended format statement, which for the first time included GIS, geospatial and 3D data. So that was an interesting document for us. And we also looked at the National Archives Pronom Technical File Registry to see what the National Archives recommend and are aware of. And I think it was Gregor yesterday who said there's no trustworthy data without digital governance and digital preservation. So I'm hoping we are on the right track here. And this is not a project, this is continuous improvement and developing our preservation capability over the years. So what we did as part of the recommended file formats work, I got one of our data scientists to have a look at one of our main shared drives where our researchers keep their active data. Sometimes they keep it far too long. And we discovered out of that 560 terabytes of data, which covered about over 12,000 different file extensions. And I can share with you that many of them were manually altered. So we had file extensions .bgs and all sorts of things there. So we couldn't validate all of these, and they are not archived data, they are active stored data. One of the downsides is it's not accessible for the public, so we need to work on that. However, 50 of the most common formats covered over 43 million files, and that's about 90% of the content. So we don't think we need to cover all 12,000 file extensions at this point, even to validate, because we want to do good work. We don't need to do gold standard on day one. But you can see, for example, CSV is a top file extension there, and JPEG and ASC files as well. We did a bit more analysis on the top 30 and noticed quite soon that 1/3 of them are Esri ArcGIS formats, which are on our preferred formats. And there's some others, I think, processed. The first white one is manually altered as well. And there are some with no file extensions, so we need to do some more work on those. And the other formats that are in the top 10 are AGS format, which is a geotechnical data industry standard. There's a lot of TIFFs or GeoTIFFs, which is a corporate image file standard. We do accept the latest MS Office because we get data from so many different quarters. It's impossible to mandate open or PDF files. And we have seismic data in MCED as well on the top list. So the work done last year, we invited feedback and received it from a lot of staff. And the current list still needs some tweaking because some of the feedback came after it was published. So my geospatial colleagues recommended that any vector or raster data that is readable from the GDAL or OGR libraries can be supported. So we are going to add that as well. And for shapefiles, optional recommended files currently include for ArcGIS. In future, we will include the GDAL QGIS to have a different set of complementary optional files. And also we'll prioritize formats that can be validated against a schema or a published set of rules. So that's not an inclusive list there, just a few examples. This list is not a Bible. It's used as part of a wider strategic context in our preservation planning. So we are looking at what can we afford to do, what can we not afford to do, what do the end users require. But we do need something because we can't support too many formats. We also have a lot of legacy data in various formats. So this list is it's a work in progress, and we are learning lessons from both the digital preservation community and from a GIS community. And the work in the project at BGS. So these, we are coming now to the part of talk where I share my colleagues' geospatial data standardization issues with you. So there is a gold standard, which would be defining a standard set of formats and collecting data using a standard. So we have a corporate tape archive system where staff store their corporate standard data sets in usually S3 shapefiles and the associated documentation. They avoid the use of geodatabases there. There are some files normalized to either JP2 or TIFF files for web delivery purposes instead of delivering them in shapefiles. And we also need to ensure that any spatial referencing files are converted to avoid creating orphan data files and keeping them all together. In the corporate area, we keep new versions of data, so that leaves us with an issue with the old versions, which are critical to retain. You remember we have those licensed data sets, so somebody could come back to us and say, I used an older data set, and why did you have this information, this data there, because the new one has that. So we have loaded all the old versions into the corporate Oracle database and store them there as an archive of either old version published or licensed data. There are several conflicts in play though, because we have to deal with the BGS or other researchers. We get those external deposits where we have no impact at all how people generate and create their data. And there's also overseas projects, of which I'll tell you in a few slides time. And we are trying to ensure that all the tools are available using the research data management policy and best practice at the data generation phase, and then looking to tie that to the new digital preservation policy and standards. So standards from this conference that we are hearing about are very useful for me. Another example from my colleague is knowing what the coordinate reference system is, and this is familiar to all of you. Because every transformation from one CRS to another has the potential to introduce error, and that's where digital preservation is important, because you have to document the error so that future generations can understand that. And my colleague told me about the different ways this has an impact. So some spatial data formats encapsulate this as part of a single file. Some allow it to be in an accompanying file. Some mandate a specific system. And it's sometimes, because you're an expert, you just know what's expected. But we prefer a format that encapsulates the CRS, for example, WKT2. In preservation circles, open formats are often preferred to anything else, but with S3 formats, that is a standard. So we, of course, have that on our list. It may cause issues when sharing data in our working life. And luckily, most software today has some import and export tools, which is great if you still have the software and have the license to use that. So for archival going forward, we need the data in both the original format to ensure there's been no loss of data, and in an open format to enable long-term sharing and preservation. And the benefits to our staff of the open formats are they are not tied to any platform. They are standardized. Strictly open standards can be extended, and sometimes they use the word misused or overloaded. So you can report they are geo packets, but they are really full SQLite. I promised to tell something about our overseas projects because we do a lot of overseas development work. Part of our funding goes towards that. It must be spent overseas. So usually African projects where there's shortcomings. They may not have large format scanners. They have no access to particular software, or they have illegal versions, prefer to use that. No power supply or bandwidth to share large data packages, or they've had training courses and produced data in that package, but they can't use it, or there's no metadata. And even if there's a big project like one in Kenya, published a functional GeoNetwork metadata system, it still relies on JPEGs and PDFs in the background. My colleagues also work with the UK Geospatial Commission, which is an expert committee setting out the UK's geospatial strategy and promoting the best use of geospatial data. And we are one of the Geo6. So the other members are the Ordnance Survey, the Coal Authority, Her Majesty's Land Registry, the UK Hydrographic Office, and the Valuation Office Agency. And my colleague Ed Lewis has been working with the Ordnance Survey to review standards of the UK landscape to identify what needs to be done. So they selected standards using the 7 principles from the UK Cabinet Office policy paper. There's a link on top of the page there, open standard principles. And did 2 user engagement surveys as well based on those principles. And the following slides are recommendations from the results of this review and the user surveys. So first one, they recommend using stable standards and adopting them. So the UK Gemini, which also takes into account the needs of Inspire. The Internet Engineering Task Force, JSON, and the Open OGC's GeoPackage and GeoTIFF, and then also using GSV and WKT. To support adoption and user engagement, using JSON and GeoPackage to migrate from S3 shapefiles, and using API delivery, which we also have on our website. So different ways of making that data available. Further recommendations from that work, my colleagues are working on standards which need development within the OGC, and they relate to the API tiles, map styles, and records. And they are all coordinating the Geo6 involvement in this work. And the final couple recommendations from that work, things that need further investigation are semantic standards and controlled vocabularies. So we, for example, have several corporate vocabularies to do with geoscience. There's been a lot of work done in linked data and the special data on the web best practice, and looking at the data quality and the UK public sector framework. And finally, standards including reference data. And the last example from the Geospatial Commission is another project which has captured data from hard copy data. That is the last slide.
Okay, thank you.
Geo6 holds significant amounts of physical data that has not been digitized, and as a group, there's more impact and possibility of making that accessible and sharing the cost and learning from each other to use new technologies on those data that are not in digital format yet, like AI and ML. And those guides are available online if you want to have a look at it.
Thank you, Jaana. This has been very. There was your last slide. Thank you very much for your very elaborative presentation. It is very clear that you are not working on a project, but it's a process. You are dealing with loads of information, also very expensive information to connect. And you have all kinds of principles and methods to archive those data. So thank you very much for that. There are a few questions for you. I would like to still pose a few questions, but a rather limited amount of time to answer those questions. The first question is from the Slovenian Archives, and she asked, is all the electronic data instantly available for public, or do you have some data somewhere off storage because of lack of space on your system?
We are sharing some data sets with another NERC data center, so there's no lack of storage. However, we have data under embargo after academic projects, so people have time to write up their research before we publish the data. And there are some commercial data where we have license in place before we let people access that.
Okay, that is very clear. And do you pass that information, this license information, onto archives, or you just don't put those commercially protected data in archives?
They are stored in the same place, but any restrictions are captured at the ingestion phase with the metadata, so we can track that down and release it when the data becomes available.
Yeah, thank you. And I think that is a clear answer. Do you have any automatic format validators? I think you do, because you have explained some tools.
We are still implementing tools because the preservation program, the technical side, is quite new. And it is in the work program for this year to implement, for example, checksums, fixity checks, and more validation tools.
Okay, so I think that Tina certainly will get in touch with you about this format validators. And then Gregor, he has also a question. Does the Ordnance Survey or UK Archives issue any guidelines on how to preserve geospatial records, and where can we find the documentation? Maybe.
Yeah, on one of my last slides,
yeah,
there was a link to the guidance. So
yeah,
and there's also a blog how the guidance was built, so that's also of interest, I'm sure.
Okay, well, your presentation certainly gave food for thought and food for further work. So thank you very much for your very.
Sorry about taking too much time.
Yeah, it's okay. Thank you very much. It was very interesting. But I would like to go to the next speaker, Jaana, which is Juan. Joan, can you hear me?
I believe I can. How are you today?
I'm doing very fine. Juan Maso on preserving data with or should I say the Open Package Convention. He works as principal investigator at the Center for Research on Ecology and Forestry Applications in Barcelona, Spain. And he has a very long track record in remote sensing, GIS, map distribution, viewing technologies, such as Miramon, GPEC 2000, and the Open Geospatial Consortium, open standards such as Web Map Tile Service. And he's the author of different standards such as ISO 1965 and 29500 OAIS and the GeoCITS. He will explain the standards and methods that are needed to guarantee that information can still be recovered and reused on the long term. Can I please give the floor to Juan?
It's definitely a pleasure. I would like to present this idea of preserving data using Open Package Convention. I'm Juan Maso. As you said, I work at this organization in Barcelona. It's called CREAF. We do mainly ecology. That's the E in our acronym. But we have other lines of research, and in particular, we have this big data and data quality. and that is where I suppose I'm better set. I do also Earth observation and so on, but the preservation activities are in this part that we could define as data management. Yeah, the concept of the context of my presentation is this 19165-1, the preservation of digital data and metadata fundamentals. I was participating with my colleague in the production of this text that maybe it's probably could be reviewed and do better, but was our first attempt in the family of standards for geographical information produced by the technical committee to 11 to approach the topic of preservation. The standard sets the rules for a long-term preservation of digital geospatial data. This data includes also the metadata and other ancillary data that are necessary to fully understand and rebuild the archived digital environment. The geospatial data is preserved as a geospatial archival information package, and the standard defines some details on how to improve the metadata to actually include context, and also suggest a practical implementation of the information package that is the focus of my presentation today. One thing that we all know is this standard data model, the ISO 14721, that tells us that apart from the data object, we need to preserve all the other stuff in order to make it understandable for future generations, even if the acknowledged body that they have or the designated community knowledge that they have has changed over the time. So there are several other elements that needs to be considered when you create this information package. And I'm taking this from this illustration from this CITS Geo version 2.0 that I'm sure is going to be presented in detail afterwards, to say that this is a practical representation of the previous standard that I just mentioned. And there is a lot of documentation and metadata needs to be added to the geodata to make it comprehensive. And this is one representation that takes a shapefile as a possible standard for preserving the data. But it's very difficult, as we have seen in the previous presentation with that graphic where several data formats were discussed in terms of the number of times they have it stored, to select one format. And to make a little bit of a joke, I was looking for some criticism on the shapefile, because I know that many people don't like the shapefile because there are several limitations in the number of attributes, even in the length of the attribute names, in the size of the file. There is no topology, etc., etc. So it is very transversal. It's widely used, but nevertheless, there are many people that think that it's not the best possible solution. So, well, we could add another representation to the package. We could make the package bigger and secure the possibility to have the data in two representations, where the goods and the bads are compensated between both representations. And the standard that I'm mentioning suggests the use of GML, and that will be commented. But again, to make a little bit of a joke, I was looking for criticism in XML formats. So there are people that say they are too complicated. There are people that say that they are not just too complicated, but they failed to fulfill the promises and other specifications that are now the fashion of the day should be used instead. And we are seeing here, and that's part of my message here, that first it was shape, then it was GML. Now it seems to be GeoJSON, though. So there is a variability in the fashion, if we can use that word, no, the fashions of the different formats that are used today. So we are seeing that one representation might not be a good idea for preserving data, and having the some in the package could guarantee the accessibility for future generations. Well, so the idea is try and create that package in a way that those elements that might be a lot of elements are being actually wrapped in a box that is called Open Packaging Conventions, and this is part of the ISO 29500 Part 2 Open Packaging Convention, that actually is the format that Microsoft Office is using internally. They have several elements, mainly XML, and those elements are packed in a single file, because that's what we expect when we try to share the presentation with, for instance, the moderator today. That's what I did. And if we open the package, and this is actually my presentation, this PowerPoint, this PPTX format that is seen in a package explorer that is compatible, of course, with the Open Packaging Convention. And we are seeing all the elements, the different slides represented in XML, also the screenshots that this presentation contains, even a thumbnail, a core XML metadata file, and this file that I'm showing you in the screen now, that defines the relations between the different elements together, and that I believe is important. So what we want is to work towards a self-explained preservation package. And we can try and use this standard to create a zip file as a single container for all parts. And here we see three, globe that represent the three formats that I was kind of joking before. And all those three formats are put in the box and are zipped together and wrapped, and that's it. The zip file incorporates a folder structure, but the folder suggests some kind of a hierarchy, but it's not clear which are the dependencies between files and how to manage those files if you do not know the exact particularities of the formats that are used inside. So this packaging convention, what it does is two things. One that is not illustrated here, and this is it is not using the extensions of the files, but is using media types instead. This solves the problem that one extension could actually refer to a couple of different formats, like XML, that is too generic, or the case where you do not have extension at all, as was described in the previous presentation also. So that's one thing. The other thing that is illustrated here is this relation file. Those are small files, .rels files, that are added into the package to actually understand that if you have a shape file, you also need to have a DBF file and an index for the shape file, and the projection for the shape file, and all the other stuff. So this is the core one that sets that there is a thumbnail, sets that there is this shape file, and also the attributes and the boundaries that were represented graphically in the previous slide. And here I'm describing the the boundaries dot shape dot rels, and there is a mistake in the title, and all the related files are related, of course, to this main document, and then anyone that needs to manage the package can know that those 4 files goes together, even if they have no idea how the shapefile works. This opens the possibility also to build tools to actually extract one representation of this multi-representation package, and that's important because then we can have the archived information package as this one that has the 3 representations, but the distribution information package could be generated automatically only with 1 representation of those, and this way we are distributing smaller things with no redundancy. We can also do the opposite. We can build a tool that adds a representation to the data package without any knowledge of the formats that are inside, just using the relations to actually guide us into the process. This is what I call a completely agnostic tool on the particularities of the geospatial formats used. And this is really, to me, this is really important for long-term preservation, where knowledge about those relations could be partially lost. So the people that are actually managing the packages don't know them completely. To test this, we did an implementation, and we called MMX thing. We call it an X just because most of the Open Package Convention files actually use the X at the end. So we thought that will give people a clue on what we are doing, and we are implementing Open Packaging Convention here, following also the CES Geo standard, at least partially. You are going to see that. So the first thing is that this tool had now a new radial that says preservation, and when you do that, then the software, what it does is to automatically collect all the elements necessary to preserve the data. So it includes the data, it includes the metadata, it includes the symbology, it includes the context, and also does an automatic conversion between the current format into the portable format, if we can call it that way. So the portable format in this case is the GML version of the vector files and the GeoTIFF version of the raster files. And this way we are following the CITS Geo proposal. The package can be automatically opened in our software without even uncompressing it. The software understands it and keep the package unaltered while showing the information. And that opens actually not just 1 but 2 applications. One is actually preserve the data for future generations. The other one is just distribute the data for an easy managed sharing into the internet as a single piece. The Catalan Cartographical Institute is using that format to actually distribute some of its products, and also the Catalan government has adopted this tool to start a preservation policy of its geospatial data. So actually, as I said, there is this replication of the information into the GeoTIFF and to the GML despite the original format. So we are packaging the original format plus the common format all together in this package. And if we select correctly the specification of the zip, and we use zip 64, we can really store big documents with no problems. We can also use BigTIFF to store big raster data also inside the package. And we add more elements. For the thematic series, we include all the components, like for instance in a topographic map that you need several shapefiles, several layers to actually describe them. All the shapefiles can be included all together. For multiband products, you can include as many GOT files as you need. We also include the shapefile white paper as well as the GOT version 6 specification in the package itself, and also the DBF description, because the shapefile white paper does not talk or does not describe the DBF part of the standard. We believe that that's a good thing to have. It's relatively small, so no problem with that. We also add a log file that details what the characteristics that the transversal format was not able to preserve. So, for instance, the lack of topology in shapefiles is actually documented for the people to know exactly the small details that might not be preserved into the transformations and could be lost. We also add a map and an OGC context file to actually help opening the data in an integrated way in a single visualization. And talking about visualization, we also add a starlight description document to actually describe how to visualize the data. Because one thing that is kind of annoying sometimes is that you get the shapefile, but the shapefile opens like a family of wires, all black in your screen, lots of lines, but you have no idea what you are seeing. So trying to preserve the styles and the symbolization is really an important aspect from our point of view to try and include that into the package. And for the future, we want that tool to actually be able to split, as I said, to split the package to extract just one representation of it and disseminate only one representation of it, to be able to add one representation of the package inside, and also to have some way of maintaining the package up to date, migrating versions and so on. We also want this package to be visible directly in web browsers without the need for an app. And I'm happy to report that it seems possible with the current technology. The XDML5 allows us for reading files that you have, and in particular packages that you have. And this is a proof of concept, a very small page that I created, where I demonstrate that you are able to actually browse through your local storage and just select one of these packages, and you can unzip the package and see the content directly. And here I'm just in each row printing what is inside and the first bytes, just to demonstrate that it's possible to do it. So now with these bytes, I need to do more. I should be able to create a representation of the data graphically, of course. But this is actually demonstrating that the idea is compatible with the browsers. And since we are spending most of our time in browsers these days, that's really important to ensure that this is going to be compatible with these new technologies that we are using every day. And well, this is the idea that I keep talking about with my colleagues here and there, how we can combine different ISO standards all together to actually advance in this idea of having easy to use preservation packages. Thank you.
Thank you, Juan. This was a very fundamental presentation also for the presentations that will still follow, because it really describes the higher level standards that are behind the archiving of data. There is I was wondering if there were questions, but there's someone who is giving me strange commentary on, and I suppose if there are any questions, can you please raise your hands and open up your microphone? Juan, your research on it's remarkable how all these standards you have been developing in the past years, and how it ends up in practical application in today's eArchiving. How does your own organization in fact practice this implementation of the work you do?
Yeah, well, I was a little bit commenting that our research institute is one of the research institutes of the Catalan government network of research. Yeah. And when I say that, I mean that the Catalan government pays something for those research institutes to work, but they expect something back. So they are asking us solutions, of course. And we also arrive to the same issue that is the focus of this conference: how we are going to preserve all this amount of digital information that the Catalan government is producing, and the geospatial in particular. So they ask us, well, there are all these standards. Can you just implement something for us? And this is what we did. We used what is out there, and we applied to our, interpretation of how these things need to be done. Well, we have been working with packages for quite a while, but we wanted to actually migrate this idea of the package into something that is very flexible. So we adopted the open package conventions. We also are also adopting current practices that we learn actually when we attend previous editions of this conference here, and with all that we created that solution.
Okay, and do you how is it received? Because I can believe that it's sometimes can be very abstract to your community, to the people who need to implement it, or don't you have that experience?
Yeah, well, we are all looking for solutions. I mean, my feeling is in the meetings we have with the different actors that needs solutions, the final solution is still not there, and we are all collaborating into finding. And what I present is a simple approach that seems flexible enough, and it aggregates many legacy standards. So that's what I wanted to tell you.
Okay, thank you very much. There are no further questions. Juan, I'm sure that you will get further questions in private chats, or that people will contact you afterwards. Your contact details or your presentation will be online, so people will know how to find further information and be in touch with you. Thank you very much for your excellent presentation and for the fundamental work you do. And I would like to go to the next speaker, who is Ann-Kristin Egeland from the Danish National Archives. She will talk to you about, she will give an introduction about the requirements for preservation of geodata in the CITS Geospatial specification. She is a special consultant in digital preservation at the Danish National Archives, and she has prepared AIPs, archival information packages, for the past 10 years with data from database for access, and is now responsible for the preservation format for geodata in the archive. She combines both computer science and history of art. She received a master's degree in Roskilde University and also in the interaction design and multimedia from the IT University of Copenhagen. So she combines really everything, the technology, the knowledge of the history, and also usability. Ann-Kristin, the floor is yours.
Thank you very much. Thank you. I will just share my screens. Do you hear me?
We do hear you.
Yes, good. I will start my slideshow here. Yes, and now I will give you an introduction to the CITS Geospatial. Yeah.
We do see you, but we don't see your slideshow yet.
So why don't you? Okay, I need to share. I forgot, sorry.
No problem.
There we go.
Thank you.
So now I'm sharing. Yes, and I will start my slideshow again. I will now give you an introduction to the CITS Geospatial. Let's see how there. And first of all, I will tell you why I think this presentation is important to you and what you will learn from my presentation. And also, before I start telling you about the requirements in this specification, I will tell you a little about what is a content information type specification. And I will give you some examples of the requirements in this specification. And in the end, I will also tell you something about what we call profiles. We could also call them preservation format specifications and how you add these specifications to the CITS Geospatial specification. And then I'll talk about what next about this specification. The aim of the eArch is to specify specifications for long-term preservation suitable for everyone preserving or reusing digital data. And that's why we would really like, we need you to review this specification that I will present for you here, the eArch, and it's been specified in the eArch 3 consortium that Anders told you about yesterday. And this specification has requirements for preservation and reuse of geodata. And we would like you to look at this specification, to read the requirements and ask yourself, are these requirements suitable for your purpose in the archive, in the library, in your company, wherever you need this kind of specification for your work? I will give you a brief introduction to the hierarchy of the eArch specifications, because there are quite a lot and you need to read all of them to be able actually to understand this CITS Geospatial as well. And after my presentation, hopefully you will also know how to read this CITS Geospatial specification, so it's not too technical or too difficult for you to look into. And I will give you some examples of the requirements just to give you an idea of what kind of requirements are written in this specification and what kind of requirements are written in other specifications. And one of our key messages in this presentation is that this CITS Geospatial specification is a modular specification, and it's suitable for packaging and preserving all kinds of geodata formats in a CZIP. Jaana just told us that they had found, like, was it 12,000 different formats, and this CITS Geospatial doesn't have any requirements on the actual preservation formats that you put into this information package. However, in this CITS Geospatial, there's a recommendation on how to use other kind of specification, for example, ISO standards or other specifications that are more that specify requirements for the actual preservation format, like GML or GeoTIFF or any format for point cloud or whatever, or BIM. Yes. So what is a content information type? What kind of requirements is specified in here? These are the requirements that are unique for a specific content information type, for example, like geodata, as I will present for you today. And the kind of requirements are, for example, how to write a METS file. A METS file is mandatory in an information package, compliant with the common specification for information packages. I will tell you a little about that later. But here in this CITS Geospatial, for example, there will be some requirements on how to fill out this METS file. Also, there can be requirements for folder structures in an information package. And basically, it's requirements on how to place and group files in this information package, but also recommendations of what kind of metadata and what kind of documentation to place in an information package, for example, when storing geodata. And also, recommendations on what preservation formats and standards you could use for both data and metadata. And once again, I'll just say clearly that there are no requirements on the specific preservation format. For example, the formats you should preserve vector data in or anything. These are defined in other specifications. And this slide gives you an illustration of the hierarchy of the eArch specifications and also how these specifications use other standards. And the first specification important to know is the CCIP specification. That's the common specification for information packages. And basically, this specification has requirements for the information package structure. Below, the eArch project has also specified a CIP specification, AIP specification, and a DIP specification. And these specifications only add further requirements to the CCIP. For example, if a requirement is optional in the CCIP, maybe it is then mandatory in a submission information package. And then the level below is the content information type specification, which I will present for you today. And I show you this slide just to make it clear to you that when you read the CITS specification, there will be references to other requirements in the other specifications above, for example, the CCIP. And the CITS specification, again, just add further requirements to the CCIP specification and the CIP specification. So you really need to read all of them or follow the references to understand the requirement in detail. And then below the CCIP specification, there can be what we call profiles, or what I call here the actual format specification that actually define the preservation format for some kind of data, for raster data or vector data or satellite data or whatever. And all the green boxes just illustrate what other standards these eArch specification is based on. Yes, and before I start telling you about the CITS Geospatial, I would just like to draw your attention to the fact that there's also a guideline to the CITS Geospatial, which is may be much easier to read, because in this guideline, first of all, we have made an introduction to what is geospatial data, what is vector data, what is raster data, and so on. And for each requirement in the CITS Geospatial, we explain what we call the rationale. And what I call the rationale is, why do we have this requirement? Why is this important? And as you can see here, there's both a description of the requirement, there's an example, and then there's a reason why this requirement is important. Yes, so let's get on with it. This is a CITS Geospatial requirements, and my first slide here just show you the table of content, or some of it, from the specification. And the specification has a total of 43 requirements. And as you can see here, there are requirements on the folder structure, on the METS file. Then there are some general requirements for information packages with geodata, and then there are more specific requirements for information packages with vector data or raster data. Of course, geo-referenced vector and raster data. And also there are some requirements and recommendations on what documentation to put in an information package with geodata. Sorry about that. And also some recommendation on what metadata files to put in the information package. Here are some examples of the requirements for the folder structure. The blue folders that you see in this illustration, those are requirements from the CITS specification. And the green folders are extra requirements added to the CITS Geospatial specification. And as you can see here, as I noted, that there are 5 different folders that we recommend, and 2 of them are actually mandatory. So we would really like you to look at this and see, will this work in your context? Will this be suitable for you? And here you can see some examples of requirements for the METS file. The first requirement is that there must be minimum 1 representation. That's the representation folder holds the actual data files. And both a package METS XML file and a representation METS XML file in an information package. And you could see these are the yellow boxes. There must be an XML file at package level, and also at representation level. This is not a requirement in the CITS specification, but it's a requirement in this CITS Geospatial specification. And the reason for that is that we don't want too big METS file. The bigger they are, the harder they are to validate and update and process. So this is just an example of why do we have this requirement, and you are welcome to have an opinion on this as well. Also in the METS file, there are some use of some vocabularies on how to group the data in the information package. There's this element called type, and then there's a vocabulary of different types, and the one that you should use when you make a CITS geospatial information package is the value geospatial data. So that's a requirement, and it's mandatory. And then again, we ask ourselves, what is this used for? Well, it can be used for identifying or grouping information packages with this kind of information at a very high level. And there are also the Geo3 requirement here. This is another level. It's called geodata right now, but we're still working on that. But this information, the geodata value in the METS file, should actually be able to be used for validation. And actually, it should reference this CITS specification, this CITS geospatial specification. So we would like to have a value that really, actually tell. Maybe it's called CITS geospatial, just to know exactly what it's referencing. Geodata and geospatial data is kind of the same word. So we're still working on this, and if you have an opinion, please let us know when you read the specification. Now I will just go through some of the general requirements. These are quite important. So I will go through all of them. First of all, there's a requirement that there must exist at least 1 file in a geospatial format in a representation and in the data folder. Because if we don't have any geospatial data, then it's not a CITS geospatial information package. The Geo12 requirement is that each geospatial file could be placed or grouped in subfolders. So And this is also a requirement in the CCIP, but we just stated here as well. And this is also to ease validation, to know where to find the files in the information package. We don't specify how you should do this, but we recommend that you do it. Also, there's a requirement that the information packet must contain at least one representation of geospatial records in a long-term preservation format, as defined by the archive or somebody else, or in the long-term preservation format profile. And there are much more about that in the specification. And these profiles, I will talk a little about them in the end. And this requirement is here because this is a specification for preservation. So we really recommend that you do have a long-term preservation format as well in one representation, and then maybe you can have the original format in another representation, just as Juan just showed you in another slide. Yes, the information package could contain a separate, that's what I just said, that you could have the original data as well in another representation. And here is a requirement that is quite relevant as well. Every geospatial data set must be accompanied by, with the information about its underlying coordinate and reference system, just like Jaana just told us. Was some of the feedback from her colleagues that this information about the coordinate and reference system is really important. So we have requirements on that as well, or the specification have requirements on that. And it even recommends that you use standards for this CRS, like the VK2T2 format that Jaana just mentioned, but you can read more about that in the guideline as well. Then we have a requirement, the 16, that the geographies in the geospatial records should be located within a fixed bounding box defined in the submission agreement between the producer and the archive, according to the expected location and extension of the data set. And this is for validation purposes. Often migration, if a migration go wrong, then the coordinates will be placed outside this bounding box. So this is just one way of catching this on validation of the submission. Then finally, every geospatial data set must be accompanied with a metadata file that describes the data set with the basic required information. This could be an Inspire metadata file or another ISO standard used for this. Yes, I can't really see the time. There we go. Then there is some requirements on how to document the geodata in the information package, and it's described, or it's there should be both documentation on the content, the context, the structure, the rendering and visualization, and the behavior. And this is just one example. For example, a document containing definitions and descriptions of feature types, its feature attributes and feature attributes related to all the geospatial records in the information packet must be provided. And this is a way to describe the content of the information package, but also the structure of the data. And why is this important? Well, it's important to be able to understand the data, to be able to reuse it in a correct way in the future, or now as well. Yes. We recommend the use of standards for the metadata, the geospatial metadata in the information package, for example, Inspire or the ISO 19115 or 19165 that Juan just introduced to us. And this is just an example of this kind of data. Yes. Now I will say what I just introduced to you and showed you examples of was the CITS Geospatial specification. And in this specification, there's a recommendation that to use profiles or preservation format specifications for the content of the information package. And in these profiles, there are further requirements for the actual file format, or how to, as you, Juan, just told us about, how to describe the relation between the files, because that depends on what kind of information you put into the information package. If I have an illustration here and with a GML file, and this streets GML file is validated up against a schema file, and how do you describe that this schema file validates this GML file? It can be done in many ways. It can be done inside the GML file with a reference to the schema file. It can be done by grouping them into one folder, or it can be described in the METS file. There are many ways to describe these relations, and Juan just showed us another way to do it. Yes. Here are some examples of profiles that we have worked on, and we will work on in the Danish National Archive. When we will implement the specification, we will have the need for a profile for how to preserve vector data and a profile on how to preserve raster data. For example, the vector data preservation format could be the GML321, and maybe you would use other kind of profiles, but yeah. And also in these profiles, there are further requirements on where exactly to place the files in the information packages. And just to say, these profiles are not yet specified fully. There are some examples when this specification comes into review. There will be some examples of profiles that you can look at, but they are not fully specified, and yeah, you can't use them as they are right now. They're just examples. And also just said, well, the point is that anyone can specify a profile, but of course, if we all use the same profiles, it supports the interoperability, and we can use the same validation and dissemination tools. So we would really recommend that we work together on this and use all the experience that we have in different areas for this. Yes. So what next? What will happen now with this CITS Geospatial specification? We had hoped that we had a review date, but it's not available yet. But everyone is working on it, so that it will come out for review very soon. And there's a release date for this specification planned for October 2021. And I, for my part, can tell you that the Danish National Archive are working on implementing this CITS Geospatial and developing preservation profiles for vector and raster data. And I would like to ask anyone here today, are any of you considering using these eArch standards, for example, the CCIP or this CITS Geospatial? Do you have any plans for that? And I would also like to ask you, Juan, was your presentation, it looked like the CCIP information package structure, but I would like to ask you, do you use this, are your information packages compliant with the CCIP specification, for example? That would be good to know so we can work together. And about the tool development, right now the eArch project is working on the validation, making validation tools for these CITS geospatial requirements. And at the Danish National Archive, we definitely plan to develop validation tools for the actual profiles, the preservation formats as well. And then, as Gregor mentioned yesterday, there will be another eArchiving webinar on geospatial data on October 14th, where we plan to introduce this CITS Geospatial and all the requirements in more detail. And if the CCIP validation tool for geospatial data is available, we would like to make a live demo of that tool as well, so we can see how does it work, and so on. Yes, that's all from me.
Thank you. Yeah. Thank you, Ann-Kristin. Yeah, just took me a few seconds to unmute myself.
Yes.
Thank you very much for your very interesting presentation that clearly explained the context in which eArchiving operates. The eArchiving components and their links to other specifications and other good practices. Thank you. I found it very instructive. And thank you also for the practical explanation of how to structure and document data and touching on the necessary elements that need to be developed further. And also to make reference to the other presentations, so we get a bit bigger overview of what is presented today. So you also said that there is plenty of work to do, and also to think about interoperability. So about the creation, not to create too many profiles. So I hope that we in the community will also give good examples or guidance to limiting that amount of profiles. And yeah, you already raised a few questions.
Yeah.
So
I had one for Juan.
Yeah.
About his information package that he just presented and the tools for creating that information package and describing the relations between files. Is that compliant with the CCIP specification, the eArch specification, or have they developed their own information package structure?
I mean,
that's an answer there. Yeah.
Thank you, Rick. So we used or we were inspired by a previous version of the CITS specification. Our approach is flexible in what the package should contain. We are just offering this idea of this technological way of having the box and then the relations between the elements in the box, and we will love to make it compatible. And we are here to learn about the progress of the CITS specifications and what we need to do.
Yeah, that's great. And we are here to learn from you, from you actually doing it out there. Yeah, so you know what works, what doesn't work, and so on.
Okay, yeah, thank you. This is very, thank you, Juan, for your very good answer, very clear and concise. I also have maybe a little bit technical question, which is also already partly answered by Juan. But you were also somewhere, and Gregor also addressed it, about the bounding box help determine the search area in which the data set is. But I know that there's also in ISO 19115 specifications possibility to draw not only bounding boxes, but also to polygons or lines or points. And I know from experience that older maps, they are not rectangular maps. And of course, for a first impression of where it is approximately, it is very helpful. But for example, if you have spatial search engines, then you will end up with these bounding boxes with a lot of clutter, in fact, in the search results, because then you have matches which are not matching at all. So, of course, those are more complex to read for a human reader. What are the plans for that? I know that I'm a little bit annoying with this question, but I find it personally important to be precise. This maybe not for humans, but for computers.
Yes, Actually, this CITS Geospatial specification recommends that you use standards out there for what you need to do, and it really recommends use of machine readable formats so we can automate processes. But the specification doesn't specify exactly which one to use. It recommends some. So I think you can use it in the way that you need to. But also this this discussion about the bounding box, there's a lot of purposes of a bounding box. The one I explained was for validation and migration. That's a very specific purpose. The one you're talking about is probably for publishing data, for searching data, for identifying the right data set, and so on. And of course, there can be other formats for that, or specifications, or how to describe it and use it. So this is an interesting discussion that we should have a lot more to be wise on that as well.
Okay, thank you, Ann-Kristin.
You're welcome.
I hope your main question is answered, and your more wider question we can still address also in the break, during the break, or hopefully also during live meetings in the future. And the webinar you also pointed to is also very important, that they're also practical how to do. And I believe there are also YouTube videos online already of past events that can help the participants understand better how to practically implement the guidelines.
Yes.
Yeah. So there's
could I ask Gregor to tell everyone where the review of this specification will be published or announced, so everybody knows when they should have a look at it, because I'm not sure about that.
Sure, if you let me present.
Thank you.
Thank you for making the bridge to Gregor's presentation. Gregor Završnik is an international consultant. Everybody knows him, I suppose, already, who has previously participated in these meetings. But yes, he's an international consultant with more than 20 years working in the geospatial domain. And his clients range from the National Archives, mapping agencies, World Bank. He's working literally all over the world. And he is a very good fundament because he holds a master in geodesy from the University in Ljubljana. Please, Gregor, you are the policeman who will kick us back into our doghouses if we said anything wrong in the past presentations or give encompassing words. But please give us also some information about the CITS Geospatial specification for preserving GIS systems. Thank you. Gregor, the floor is yours.
Okay, do you see my screen?
Yeah.
Okay. Thank you, Rink. And my presentation today is actually a continuance from the presentation, from the previous presentation by Ann-Kristin. And it's basically talking about the usage of CITS Geospatial specification for preserving GIS systems, because this was one of the tasks in the eArch 3 project. The first task was to update the first specification that was published in the previous release that Juan Maso referenced before. And based on the feedback from different organizations from the archives, we have fundamentally restructured certain elements to be more in line with preservation practices in the archives and to simplify some things. And on the other hand, also to actually offer not just preservation of geospatial records themselves, but also GIS systems, and to a certain degree, of course. And I will explain why and how. So the whole presentation will focus on the evolution of the CITS Geospatial that was presented by Ann-Kristin. So to somehow show you how we came from the 2.0 version to the current version that is about to be released. I was hoping that the release would come before the conference so we could already link a download link for you guys, but it wasn't possible. Then the next step is going to be the preservation practices implementation, how we approach this and how this influences the structure of proposed folders. Then why preserving GIS instead of just preserving data sets, and some elements on how to use CITS Geospatial specification using the guideline for GIS to preserve the system to enable us to reuse the information products. And of course, steps forward. So on the screen, you see the first proposed structure of the GeoIP, which is the version 2.0 that Juan Maso referenced in the beginning. And this one was actually adopted in some aspects. And then since we need to be compliant with the general structure of the information package of the eArchiving building block, we changed the structure in the version 2.04 that went out last year in October, and we got some feedback on it. And as you see, it's a bit different, and you see the differences. The blue boxes are the boxes that inherit the proposed structure from the archival package, and the green boxes were the boxes that we proposed. However, even after that proposal, we got some new feedback to restructure it and simplify it. And as you see, what we did was we dropped the technical documentation folder and the contextual documentation folder and just focused on the key categories that are used in preservation, which are structure, rendering, behavior, and context that we named other, so that we can then use interchangeably also possibilities within representations. As you see, this is a representation, and you have the same types of folders here as you do here. There are some specific ones within the representation that are needed for support of the machine readable access and manipulation. But basically, this kind of is the change that we got in the latest version. Due to such changes, it will probably renamed to a version 3.0 because it's not just an update to 2.1. So you will see the differences when it's published. Now, the second thing that also was mentioned by Ann-Kristin and commented by Juan Mata before is that the CITS Geospatial evolved its approach to formats. In the first version 2.0, we proposed the formats to be used in geospatial preservation. However, now we don't specify any mandatory long-term preservations. We just mention some very viable candidates because we still can enforce the preservation formats using the long-term preservation format profiles, as Ann-Kristin mentioned. So the idea is to gather as much profiles as possible from any archive, any organization that uses strategies to validate. And the profile actually is just a set of validation rules on how to validate a certain format that is used as a long-term preservation format. This will enable us to adopt, to broaden the adoption of the specification in different types of organizations that maybe have less strict preservation policies. As Jaana said in the beginning, in their projects in Africa, they are stuck with certain types of software, so they cannot convert. However, our idea in this specification is to have a checklist of necessary technical documentation and documentation, as we call it, to describe the data so that it can be reused, even if we can convert the file from an Esri geodatabase to a shapefile or to a GML. But if we don't know what the columns mean, if there is no metadata, no description of attributes, or no coordinate system, then this is not possible. So this brings this specification more robustness, because we will have additional formats and types of data being developed. We already know that we have the point clouds, the the drone data, oblique images, and so on coming up as geodata that is going to be preserved. So we need to have some general specification of what elements need to be inside. Now, how did we align the specification with the preservation practice? First, by focusing on the identification of the significant properties of the data set or system in this manner. Because the GIS systems generally can be preserved as a simulation, in a simulation environment, which is a quick solution, rather quick solution. However, this solution does not support connectivity to those systems through machine readable access for AIs, for big data applications. So we need to somehow preserve elements and make it possible to reconstruct the system for the future use to a limited degree, of course. So we focused on these 5 categories that are defining the significant properties, which in our cases are content, basically geodata and database systems that contain geodata or can contain additional textual information. Then, of course, there is context, and usually metadata describes the context of the data very well. However, we also sometimes need some additional documentation, which could be like feature catalogs or something similar. So this is also developed in this CITS specification. Then the structure of how data is structured is something that is actually stored in a GIS and not in a database, because the way we structure the layers in a GIS tells us what kind of information product we'll get out of it. And this structure and organization of records can also be stored to be reused. And I will show you an example of a standard later on. And of course, rendering. If we have a data set, we need to know how to render an individual data set or a whole set of data sets to produce a map. And this can also be stored in a standardized manner so that it can be reused in a different system later on. Of course, there's a challenge by storing behavior, and we have proposed many different approaches. One is by using the storage of scripts, Python scripts, SQL scripts, and so on. And the other is to just store some videos of screenshots, how data was used, and so on, to give us a general idea. So there are possibilities, and everyone can propose their own presentation or behavior preserving strategy. So to now focus on why should we preserve a GIS or the logic behind the GIS and not just geospatial records is because I would like to show the difference. This is a slide that I show a lot, but there are probably a lot of people who are looking at this for the first time. So if in the bottom we see geospatial data records, let's say vector data, raster data stored in a database, maybe some additional lists and code pages, tables, or models, workflows, these themselves do not produce the end product. So if we have the flour, we don't know how to make the bread if we don't have the recipe or tools to make it, or an oven. And that's what the GIS tools actually offer us. And GIS tools are actually tools that help us organize the data, conduct queries, use cartographic projections and transformations of the data, and also using rendering elements like symbology, and create new data by geoprocessing, using some processes that create, let's say, buffers or intersects and so on, and exporting data to different elements where you can then receive some behavior and different types of information products like lists or a map on a screen or a map on a paper. So what we want to do is have the ability to preserve the recipe to create this map based on the vector data, raster data, and the databases that we have available. So this was our aim in this specification. We also noticed that sometimes we have a very complex information product that is brought from different databases, So this specification also supports the preservation of this. Now, if we go to the CITS Geospatial, we see the content of the CITS Geospatial. These are the chapters, similarly as they were presented by Ann-Kristin. And the guideline for GIS actually just takes the specification and focuses on those requirements that can be used to save a GIS system. And it specifically documents how to use the additional 12 requirements were documented on how to use them to actually store elements of a GIS system. And in red, in yellow, you see the information that is being added. Basically, in the beginning, we have a structure that defines a chapter that defines an introduction to GIS for those archivists that are not very GIS savvy, and also some preservation strategies that we learned along the way. We focus on some changes in the general geodata requirements, some changes in the geodata requirements. We add additional elements to define structure. We define also possibilities of defining structure for the whole GIS system and software and algorithms. And an important thing that in a GIS where you have different data sets from different coordinate systems, there are transformations. This is something that is usually not stored with the data set itself, but in a GIS system, we would like to store this so we know which transformation was used to do that. So the specifications are similar to those that were shown in the previous presentation, with one major difference in the general geodata specifications. If you're storing a GIS, there's a possibility that you have no data sets of your own. So you can store a GIS without having any geodata inside. And why is that? If we see that there's different types of GIS systems, in a standalone system, that's not the case. You get the data from files or databases and you produce a map. In an enterprise system, you can have the data in your organization and still produce a map. But today we are faced with so-called distributed systems where a system has only references to external databases. So any person can create an information product based on those databases. And if that person is actually creating an official document, we need to document how this was created, which databases were accessed, so that we can then replicate it in the future. The next addition was adding some structure information, structure elements for raster data, supporting grid indexes as separate data is suggested, tiling index files. Then we have a possibility to store a GIS project, and we propose a structure by using the OGC standard OWS context. I also know that Juan Maso was part of the team that developed it. However, this is not mandatory. You can use, let's say, QGIS project documentation or Esri project documentation, whatever your organization is using and is confident that it will be able to reuse in 20 years or 10 years based on how we want to do it. Our proposal for OWS context is mainly because it supports open standards, it's text-based, it stores the structure, some metadata, it stores the rendering elements, the queries and so on, and it's really an open format that is human readable basically and can be reconstructed in an application in many years to come. However, there are the tools for this adoption are lacking. So maybe if you choose your own, you just use this requirement and use it with your own standards. You can make your own profiles for preservation of GIS project structures. Then we also support the storage of software and algorithms using any documentation that's available, because we shouldn't be picky because people don't have a lot of time to preserve data. and whatever they give us, we can then store and make something out of it later on. Just like Jaana said, they're not into golden data packages. They just want to store anything possible so that it can be reused and then maybe make it better along the way. Of course, we want to also preserve the coordinate reference system information and requirements. This can be documented with a text, with the documentation as a document, or in a machine readable way using open standards like the WKT, what known text files, or you can store a whole EPSG database which contains all the different systems that were used in that period, which then provides different transformations and everything that is available in a standardized format. So as again, we see that the preservation specification is open. It basically is like a checklist where you see which elements need to be there. However, you decide what is best for your organization. And I think that the archives will have more strict regulations, and let's say other organizations who don't store the data for such a long time will have their own formats and their own profiles. So what's next? First, the document review. We are not having the final date yet because our team is very busy and we basically had a very little time. Just so people we were allocated 3.5 months for developing of this GIS guideline. What we want you is send us your interest. If you want to be informed about this specification, if you want to review it, if you want to see it, send us an email, send us a request through the onboarding page of the CEF. You can send it to me, Gregor at geoarh.si, or go to the dilsysboard.eu. The release date after review will be in October 2021. We also would like you to contribute through the DLM GeoForum Geo Users Group. We have meetings 2 times a year and organize events. So as you see today, we all want to talk about a lot of things. And we would like to take the specifications from context to concepts to practice, because the pilot implementation has not been done for this guideline for GIS, and this is something that is needed in order to see if there are some real-life obstacles from our concepts that we designed. And of course, feedback from the community is very important, and it actually changes our specifications day by day, which makes them more and more adaptable. So to remind you again, this eArchiving Building Block webinar is going to be on the 14th of October. And thank you for now. I hope I'm not too much. And maybe just to answer the first question I saw from Juan Maso, how OGS can help with this, is of course, when we have the specification ready for review, we will send it to you so you can disseminate it to your colleagues or anyone in the archiving working group, and this will probably get us a lot more feedback, and we just need to talk more, and we need to work together more, and so on.
Okay, thank you very much, Gregor, for your excellent presentation. You were not out of time, you were in time. Thank you. We just started a little bit later, so I think that everybody, including you, should be able to give the full presentation. And Anja just proposed that as well. So I don't know if there are more questions. Thank you also for addressing the specificities of GIS that is more richer than just pure geodata. And I suppose, I'm sure that this will be further elaborated in the future. Also, if we work closer together with the producers of data, which we will also address in the panel discussion, I suppose. And this is a process of years, and you already did amazing steps in the past years with the eArchiving as an evangelist. And yeah, I'm very happy that we are all part of this of your team's project. Not only you, but your whole eArch, of course, team project. Gregor?
Yes, thank you. So if there's any more questions, I can answer them now. If people want to have a break, then we can just have them later on, or you can send me an email. Otherwise, what is the plan regarding the break? Are we having a 10-minute break or a 20-minute break, so that I know?
Sorry. Anja proposed that we should go over time and let people catch a brief before the roundtable.
So for the plan right now, the plan is for a 20-minute break. And so the break will last till 11:30. That'll give time people to make a cup of coffee, have something to eat, take a breath, and we will see everyone back at 11:30. Hello and hello and welcome back to. I hope you all still stayed after the break. We are getting a little short on time, so let's just jump right into it. First of all, I'd like to thank Rink Kruk for the great moderation that he did in the previous section before the break. Thank you so much for that. And also thank you to all the speakers and their lovely presentations. They were super informative, and I think everyone found them just as engaging as I did. But now on to the next section, the panel discussion called The Impact of New Technologies in the Geospatial Industry and Their Impact on Preservation and Reuse. And for that, we have our moderator, Gregor Završnik, and he will lead the roundtable from here. The floor is all yours.
Yes, thank you. And we are coming to the final section of this conference, where the idea is to somehow round up the ideas and talk about topics that we have more informed decisions to make based on the knowledge that we received in the past 2 days. So maybe just an introduction to the whole idea for this roundtable is based on the things that were said yesterday morning, that the digital strategy of Europe is to become the lead in digital innovation, which definitely means that as an economy, we need to start creating an infrastructure where we can become this lead innovator. And if we look at the development of data-driven economy in the world, we have at least 3 great forces. One is China, one is United States, one is EU. And our idea is to adopt the new technologies to innovate and be faster. But in order to do that, we need to know what the use cases are, what the availability of resources is, and what new technologies we can expect so we can prepare for the upcoming technologies. And the upcoming technologies generally bring good things and bad things. Good things are definitely the new technological advances that help us do things faster, better, cheaper. And on the other hand, we have new technologies that bring us new issues, like how to preserve them, how to make them interoperable, how to connect them to other data, and so on. And in order to understand and address these challenges, we need to see different perspectives from different types of users and different types of stakeholders in this domain. So that's why I invited to this roundtable 4 speakers that come from different backgrounds. We have today with us Mr. Hrvoje Stančić, who is an acting Vice Dean for Organization and Development and full professor at the Faculty of Humanities and Social Sciences. Then we have Mr. Dalibor Radovan, who is the head of research and development sector at the Geodetic Institute of Slovenia, and Ann-Kristin Egeland, who you remember from the previous section, where she presented on CITS for Geospatial as a special consultant in digital preservation at the Danish National Archives. And of course, Mr. Rink Kruk, who is actually a strong networker and skilled in making communities collaborate that are not used to work together. And he's actually one of the rare people who has intimate knowledge in the preservation and geospatial domains. And in order to start with this discussion, I would first like to ask each of the panelists to answer some of my questions, and then after they present their idea on what they see as challenges and how they would approach this topic, we will open the questions for the larger audience, and the idea is to somehow start the conversation going. So I would first like to invite Mr. Hrvoje Stančić, who is, aside from being the professor, he's also the editor of the book Trust and Records in an Open Digital Environment and co-author of Archival Dictionary, English Creation English. And he also worked on a lot of European research teams. He was a director at the Inter Pares Trust International Research Project, where he led the blockchain-related research study resulting in the trust chain model, addressing issues of expiring digital signatures in digital records, and so on, and so on. So welcome, Hrvoje. I would like to ask you if you could tell us, what do you think the challenges in this community are? What do you think that we are facing based on your experience and your knowledge?
Good morning, everyone. Thank you for the invitation, and I'm glad to be part of this panel. I have prepared a short presentation. Do you think this is the time to share it, or we are just starting the discussion? We don't hear you. Your mic is muted.
Okay. Yeah, I would invite you to share it, because the idea is to show what you think are the technologies upcoming, and we need to embrace them in order to move on the story of preservation, digital preservation in general, and the preservation of geospatial data as well.
Great. I have just shared this presentation with you. I hope you can see it. So, yes. Great. Thank you. So I have prepared just a short presentation. It will last no more than 5 minutes, I hope. And I have titled it AI, which stands for Artificial Intelligence and Crowdsourcing in Geospatial Visualizations. So I just want to use this opportunity to share what we have just started to do, and to see how we can create or use some new, some call them disruptive technologies, and mix them together in order to achieve something of importance, and that is to enable our researchers to take just one look and then grasp the situation by using geospatial visualizations. So I'm perfectly sure that we all are aware that heritage institutions face challenges in the information society, precisely because of the emerging media technologies, which definitely change our information landscape. They create some new habits with our users, and we as institutions need to respond to that. And possibly redesign our relationship between users and our institutions. So, in my opinion, the traditional practices of archiving need to be a little bit transformed in order to be able to respond to these new challenges. So, artificial intelligence, in my view, is just a broad term in connotation to many underlying technologies. And in my view, it is always sort of an elusive term. So whatever we still cannot achieve, we name as, we label as artificial intelligence. And what used to be artificial intelligence solutions, let's say 10 or 20 years ago, are nowadays basically normal technology we are using. So in the context of archives holding traditional paper records, of course, there is a digitization of archival materials in place and going on everywhere around us. But I think that we do have an opportunity to improve that process by setting it up in a certain new way, or using new technologies in order to enable us what else could be done with those materials. So everything that you can see on this slide could be connected with the process of digitization of archival materials, so that we can use the information in those materials at best we can. Crowdsourcing is, along with artificial intelligence, one aspect of these new technologies that we try to mix together and use in order to help archivists do their jobs or accomplish some tasks that normally they do not have enough personnel to do. So even more, we could embrace ourselves in gamification, accompanied with crowdsourcing, in terms of providing some benefits for those who perform better than others in helping archives either do something with archival materials or add some new metadata and so on. So what we have just started to do is a small pilot project called digitization of the food rationing cards. We have envisioned it and started it in 2019, but due to the COVID-related situation, we did not get very far, or as far as we wanted to. So there are three partners in this project, and that is the State Archives in Zagreb, Bonsai Tech, artificial intelligence, and robotic process automation company from Zagreb, and of course my faculty of humanities and social sciences. So the materials that are being digitized are materials from Zagreb from 1941 to 45. Those are the food rationing cards, and there you can find a lot of information on the members of family, date of birth, family relation, occupation, earnings, addresses, where they lived, even the livestock some of those families had at their homes or gardens. So these materials are in form of structured printed forms filled in by hand, and this slide shows how the materials look like. So based on a number of family members and their occupation and so on, they were allowed to get some food in that period. So how to approach digitization of this printed and hand filled in materials? So what we have done firstly, that we have used artificial intelligence in order to detect borders of elements. So where, for example, this surname or last name is written, or in which field on the right-hand side. You can see the cut out elements on the right-hand side of this slide. The idea was to cut them out in order not to have problems with personal information in transcription and so on. So the project phases is as follows. So first we use Google Cloud Vision artificial intelligence for detection of border and text extraction. Then we are planning to ingest those cut out elements in the crowdsourcing platform. Because of this idea, the State Archives in Zagreb became a partner in the Enrich Europeana Plus project, which is going to build a module for crowdsourcing transcription of structured documents, not just free-flowing text. Then we'll do the transcription quality control, and then we'll again use artificial intelligence to push back the transcribed parts back together in a document. But also we will use the opportunity of cut out elements in order to write them in different cells of a database. Then we might also apply the named entity recognition for identification and analysis, and then finally be able, because of the database approach, do some data analysis, mapping, and visualizations. So what we hopefully in the end will be able to achieve is data analysis and visualization, for example, of spatial and temporal occupation changes in those times. We'll be able to indicate the income by the city area. We'll be able to analyze family members, because sometimes family help, persons who help family are not listed are listed under the name of the family. So basically, you cannot find that person under their own name. We could also show or visualize different aspects of this information held in these rationing cards, and even if we want to, we will be able to create a distribution of livestock throughout the city, and so on. Many different aspects of coming out from this information could be achieved. So the challenge that we are thinking about at this moment is how we will map old street names with the current street names in order to be able to show information on the current maps. To conclude, digitization and processing of archival materials could be easy, but if you take an approach like ours, it is far from easy. And we have shown that we can benefit definitely from the mix of different technologies like artificial intelligence and crowdsourcing, and then visualization and using of geographic information systems for geospatial presentation of information. I think that if we take this approach or similar approaches of mixing technologies, we will definitely need to integrate this approach in institutional digitization strategies. I think that is something that archives need to do. Also, we should all be involved in lifelong learning, collaboration, and maybe involvement of community if we take this crowdsourcing approach. So this is my introduction and my view how we could mix all these technologies together and actually work together. Thank you.
Very, very interesting. Thank you, Hervé. And if I use your presentation to think about how we could use these technologies for geospatial data preservation, do you think it could be used to, let's say, digitize old scanned maps? Because we have a lot of initiatives digitizing old scanned maps like Mappire and Europeana and so on. and use these technologies to make vector maps based on them, because this is how we could actually do GIS analysis for the past. I know that in Austria, they had a project where they were digitizing maps from the First World War to analyze the transportation networks and how they influenced the lags and the delays in the war efforts.
Mm-hmm.
So,
yeah, I agree. Yeah, that would be great.
Yeah, interesting. Thank you. So, how do you think we should approach the upcoming Digital Europe with the understanding of these technologies and what we should actually propose for the next projects? Because this is somehow the idea of today's discussion, how to approach this to actually make this a more digitally innovative and accessible environment.
I mean, there should be what I have shown today is just one of the examples of possibilities of mixing things together. So, for example, with Europeana and Rich Plus project, they realized, okay, so we do have a transcription module, but not for the structured data. So this is just one small aspect of that. But if we take a look at what our paper archives are, they are basically big data wells just waiting to be used if they are digitized in a proper way. You know, so this is a wealth of information that is being on the paper and basically not used. So it is for us to decide whether we want to embrace ourselves only with the big data, which is in digital form and either digitized or digitally born digitally, right? Or we also want to take this approach and try to digitize what might be of interest and use the archives and go into a mass digitization, but this time in a different way, taking new approaches, embracing new technologies, and offering some new services. The bottom line is to create a situation where we can reuse this information in order to create some new value for our customers. So it is, I think, a two-way approach. One thing is what we as professionals feel that needs to be done, but also listening to the users, what would they benefit mostly from, right? And then find somewhere the solution somewhere in the middle. So if we want to create some new values and we see the opportunities for that, then I think we should be going with that.
Okay, thank you, Hervé, for now. And let's move from a professor in the digital preservation sciences to an expert in the field of geospatial data, Mr. Dalibor Radovan, who, as I mentioned, is a head of research and development sector at the Geodetic Institute of Slovenia. And he was also a teacher of cartography at the University of Ljubljana for more than 20 years. With a PhD in geoinformatics from the Technical University of Vienna, his interests lie in everything that could be mapped and geolocated. His collaboration with the Archives of the Republic of Slovenia resulted in the first proposals on how submission, archival, and dissemination information packages for geodata should look like. And basically, I can say that I use that information to build on and create the specifications. So we always say that we are higher because we stand on the shoulders of giants. And he's going to talk to us now. So I would like to invite Dalibor.
Yes. You hear me? Yeah.
Yes, I can hear you. Yeah. So welcome to the round table, and thank you for taking the time, because we know that you're in the middle of your own conference that you're organizing, but you still managed to find time to actually join us today. So to ask you the same question as I did Hervé, would be like, which technologies do you see are coming up and posing new challenges and issues or opportunities for the digital preservation of geospatial records?
Yeah, the things that mentioned, that first of all, good morning, everybody. It's still morning, I think, 7 minutes more, and thank you for inviting me to this conference. I was present 2 years ago. I still remember the broad audience coming from all parts of Europe and from many fields of work. So I'm interested about what will come out of this panel discussion. The first presentation I was looking at was by Hrvoje, who was showing us a very innovative way of using the data or providing some kind of extra data out of originals which are on paper and scanned. My role on my job is geodesy. So we are the producers of data. We are dealing with many different kinds of data, and we also see the costs and the benefits of archiving. So I would like to make a short presentation to show you what is in my head. So I'll share a short PowerPoint.
Okay.
Yeah. Do you see it?
Yes, we see it.
Yeah, okay. So I will start with introduction of what Slovenia looked like in the early 90s when we started digitally in geodesy. I was leading a short project, the result of which was a metadata catalog. It was a metadata catalog of geodatabases in Slovenia. For the first time, we tried to find all existing databases and describe them with metadata, which were more or less in public hands, so financed by public institutions, more or less ministries. So these databases were mostly simple vector and raster databases. At that time, that was the early 90s, we counted about 400 of them, which are still not archived. And I wonder how many do we have today? So this is a problem in my head. How many databases should we or must we archive in these times? I go now in the nowadays to see how many sorts of data do we have. The panel discussion is about how the new geodata industry will influence the archiving. As a geodesist, I can see a plethora of different kinds of data, and starting with LIDAR, which is a topographic surface covered with point clouds, billions of points. Then we have a sentinel above us serving as satellite imagery, which is in fact pixel data or raster data. We have emerging oblique imagery, which means slant imagery about the surface of the Earth, which is some kind of photograph. And then we have, for a number of decades already in Europe, in every country, a GNSS coarse network. So let's say shortly, these are GPS permanent points or GPS permanent receivers, which are serving us permanently and continuously a flow of differential corrections for positioning on the ground. So these are completely different data than the three mentioned before. And then we have on the sea electronic navigation charts, which are again different, which are visualizations in digital way, which is kind of a GIS on board on the ships. And then we have another special application, which is called ETOD, electronic terrain and obstacle data, which is a special derivative of topographic data for using by civil aviation, for the safety of civil aviation. And then you have heard also about BEAM yesterday, I think. BEAM is a 3D, 4D, 5D, 6D, etc. building data, which is now being enriched by geodesy, by the data from geodesy. So from infrastructure, from buildings, etc. So the databases which are in use in geodesy for a decade or more have been introduced to BEAM, which is also new. And this is again a different topologic structure. And then we have location-based services, the services which you use as applications on the telephones and other devices, which are in fact something which works as an application and uses many different types of data, which could be geolocated or not. And at the end, of course, and the last but not the least is land cadastre, which is official database, mostly consists of vectors and related attribute data, but these data are official and they are a legal framework for ownership. So not to mention all other conventional digital data, which we started to digitize in the late 80s and the beginning of 90s. So this is about the types of data that produce all sorts of problems. Huge amounts of data, weird structures, weird formats, different scales and levels of detail, many object types. Consider just topography, which usually has between 50 and 100 different types of objects in one single database. Then we have time series, which can last for many decades, or we can have continuous flows of data. The flow of data, which I mentioned on the previous slide, produced by the network of reference stations in geodesy, produces a constant flow with frequency 1 Hertz. That means one single package of data per second. And we have this data for more than a decade in all Europe for many different points. So we have also other new sensors and types of monitoring emerging right now, and data meshes which combine geodata with other data. A linked geodata is also a very important initiative in Geosphere. And we have registers with official transactions, that is land cadastre. Beside that, we have a long history that was mentioned on my first slide, a long history of historic geodetic data or geodata which are not archived yet. So I would switch to the last slide of this introduction. Is there any solution? In my head, there are many solutions, but they are painful. They are very painful for us in geodesy and for archivists, because we need a new business model of archiving. We were used to analog materials. Now we have digital materials. We have to define a new type of archivist. Archivists were historians, more or less, several years ago, but now they are becoming an IT service. we have to produce a new legal framework and redefine the role of archive. So why do we need all this? Because me as a producer, I look at the archiving at the level of the costs and benefits for me, and I see many costs. So it complicates my life, and I see mostly costs, and the benefits which were mentioned in the first presentation by HaDEA are not so visible until now, have not been visible. So we have to provide such kind of archival service that the archiving costs will not grow over the production costs or even close to them. And this discussion, as much as I have heard until now, reminds me of the beginning of 90s when geodesy started to dig into the standards, which were first studied very closely, but then it was a kind of, again, a pain for geodesy to observe all these standards, which are in many items superfluous for production of a single database. So what is my suggestion for fighting with technologies which are emerging and different types of data? We will have to select in archiving what to import and what to choose for archiving. And with that, I would like to close this short introduction.
Thank you very much, Dalibor. You gave us a lot of food for thought, and linking to all the things we said before, we agree. We would like to find some specific use cases from the economic benefits of geodata that would support the economic cost of the archiving. And but do you think that the notion of preemptive archiving, or let's say just changing the workflows of creating of geospatial records, could significantly decrease the cost that you were mentioning?
The cost could be decreased when we decide what to archive. We are now a little bit late for to have such decisions because geodesy is digital for 3 decades or 4 decades now, and I know what were the discussions with the National Archive of Slovenia when tackling this problem, and we should start with simple databases which are very important for us historically and user-wise.
Okay, thank you very much for your input. And from a geospatial expert, I will now link into an archival expert who actually has hands-on experience with archiving geospatial records. And I would like to welcome Ann-Kristin Egeland, who is also a colleague of mine in the eArch project, and we worked together on developing of the CITS for geospatial and had a lot of discussion about what are the issues, what are the problems on implementing it. And I would like to ask you, what do you think is the purpose of the archive to address future needs of the archive digital data?
Yes, this is a question that we ask a lot at the Danish National Archives at the moment, and it also addresses the challenge that you mentioned, just not you, but the presenter before mentioned that now all the the geospatial formats, but also other kinds of digital formats are much more dynamic and complex and so on. And how do we really preserve that? But up until now, we have primarily preserved documentation of information for legal decisions and historical research. And basically, that means that we have been digitizing the 2D paper format. The Danish National Archives are known for converting all digital data to relational databases or migrating it to CIF baseline 6. We are very restrictive in that way on what preservation formats that we prefer and allow. But however, right now we are implementing a new preservation strategy with more focus on preserving data for other kinds of use than just documenting the public administration. For example, for other kinds of research than historical research, and for using other kinds of methods like artificial intelligence, and also the need for new kinds of dynamic formats that we right now don't have in the archive because we convert to CIF baseline and relational databases. So there is this shift towards reuse of data instead of just documenting history and public decisions. Yeah, we live in a digital world, and the archive reflect that. So yes, we think it is the purpose of the archive to address future needs of preserved digital data as well.
And how are you doing this? How are you facing the future needs of the archive data?
Yeah, well, a part of our new preservation strategy is to implement new methods for format assessment. And with that, I mean, this is a method for choosing suitable preservation formats for different kinds of new content information types. These are for, and of course, we are addressing those formats that we haven't preserved before, that we don't really know much about, and which are quite complex and dynamic, especially in the geospatial world. But a step in this new method is to interview data producers and users and ask them what they expect to be the future user needs of these data that we are about to preserve. And this information helps us determine whether a possible preservation formats that we have in mind, whether it covers and holds all the significant properties or functions of a format that is necessary to preserve to be able to use it in the way that they predict for us. And this information from the users and the data producers can influence the choice of preservation format, or at least it can enlighten us on what information and functions of the production format that will be lost during migration to a preservation format. So I agree that it is the answer is selection. We have to decide, yeah, what can we afford to preserve, and then preserve it in a way so that it is usable as well in the future for different kinds of needs.
So do you see that the appraisal step should be created when designing the database, not after 30 years? Or do you see any weak spots here?
Yeah, well, well, that would be nice. But I don't know what to answer to. What do you mean, Gregor?
So, for instance, currently the process is that the archivist that is working with the producer goes and discusses their, let's say, records and ask them what should they store, what should they store. However, if we were proactive and when the databases and new systems were designed, would say, look, this is going to create such and such types of records. We need to have them archived. Just add additional step to create some more documentation automatically, so we don't have to think about it and find it after 30 years.
Definitely.
So this appraisal process could be preemptive and proactive.
Yes, and we actually do this at the Danish National Archive because we often meet the data producer when they create the system. They have to tell us when they create a new system for digital data, and we have to approve of it. So we are lucky in that way. So we have that dialogue, and the need for descriptions and documentation and metadata about the data that is created along the way is really important. Yeah, so definitely early on.
Okay.
But also what we often our reality is often that when this data has to be archived, all this knowledge is in the head of one person who has left the archive. So it's important to have it written down and archived before submission to the archive as well.
Okay. Thank you very much for your input.
Can I just introduce another challenge
okay.
that was introduced to me when I was attending a conference about architecture and use of standards in the public Danish digital administration. There was a presenter who stated that old data models are not suited for artificial intelligence. And then he recommended that this public administration, if they want to use machine learning in their work, they should create new data models and new structures of data suitable for this. And when I heard that, I thought, oh, this is a challenge for the archive, because we do preserve the old data models. We don't change them. We preserve what's out there. So I was just wondering, will we not be able to use all this archive digital data in the future because it's old data models? Yeah, I don't know if that's a real problem, because we think that if we preserve this digital data in a structured and system independent way, it must be possible to, if you have the need to reconstruct a data model, you can still do that if it's well documented and described and so on. So, but if any of you have an opinion on that, I would like to hear that.
Yeah, I think that on one hand, we will have a capability. The question is, how much will it cost us to be useful? On the other hand, I think that we are counting on the future intelligence of the computer systems to be able to do this automatically, because we see how many advances there are in other fields. Now, in order to complete, or let's say to go through all of the speakers, I need to move on to our last panel discussion member. Thank you, Ann-Kristin, for your inputs and challenges. They are definitely useful, and especially because they are hands-on from a person who is experienced in the field in doing this. And now I would like to invite to our previous manager of the section, moderator, yeah, sorry.
Moderator,
yeah. Rink Kruk, who, as I mentioned, is a project leader in CITS since 2009, a consortium of the Belgian Geographic Institute, the State Archives, the Royal Library, and the Royal Museum for Central Africa to join forces in opening up maps and other data by means of location online. And you had a very interesting solution that I looked at when I was thinking about preservation of geospatial data based on Esri, which is a technology I grew up in the geospatial world, actually. And I also invited Rink because being a person who has experience from, let's say, both fields, I'm really interested in what are your thoughts on maybe challenges and, on the other hand, possible solutions to the future of geospatial data preservation.
Okay, Gregor, thank you very much. I hope you hear me.
Yes, I do.
Okay. And I don't know which slide you see of the world, or that you
we see the presentation mode.
Okay.
So just go to the display settings drop down menu in PowerPoint and set. No, left.
No, display settings. Yeah.
Yeah.
I don't know if you see it. It's changing slowly.
Yeah.
Yeah, there we are. Thank you. Okay. Well, I will be relatively short, and I just have some odds and ends to address, which I noticed in the past 2 years, since 2019. But the bigger picture is that we would like to live in a connected world, and where data is accessible from everywhere, and that we can connect to all kinds of data sets to make our own story. So in fact, the end user is central. But this is maybe a little bit unconventional picture, but this is the feeling I would like to show that is existing between many archivers or archives and data producers, because there's certainly a certain tension between the two. We have seen all kinds of examples where there are no tensions, but there certainly are tensions in how to archive geodata on the producer side, and also how to accept all the data that is coming like a tsunami to the archives. And of course, what should be taken into account is that we have to be efficient. We always complain, everybody complains of lack of staff, lack of resources. So we should collaborate, I think, in building up services, opening up our information, archiving data, and so on. So there are examples, plenty of examples all over Europe. There are examples, for example, from France, where there's a central infrastructure where all data is served and archived. And there are also examples where it's not so centralized, but very distributed. So we must put the puzzle pieces into each other. And one slide that I wanted to show you was what I find very instructive for the data producer side, because at the data producer side, I can speak for my own organization as well. It is rather unclear what to archive, which rules to follow, what kind of today's technologies there are to archive data correctly, and also to guarantee the integrity of the data. Right. For many people, the data is, yeah?
You have an application open. I think it's maybe a chat or something, and it's creating a gray square that's blocking your slide.
Yeah, that is the conference application, that WebEx. Well, thank you.
There, perfect.
I've moved it out of the window. Thank you very much. So those general, but I took this presentation from Anne-Frederik's presentation, because this is a kind of helicopter view that we need at the producer sides to understand what kind of work there should be or could be done. But I also would like to address that there are, because Gregor, you asked me what kind of stuff is going on outside in the world. There are a lot of new evolutions. There's linked data, of course. Radovan also addressed it briefly. There are new standards like the OGC Open API that is currently being developed to open up knowledge through a linked way. There's also a closer integration with of location concepts in the W3C standards, which makes location more mainstream. And then there are plenty of new sources of data like satellite and drones that are flying around, or zeppelins even. There are commercial parties that produce loads of data that's also used in public services. So what should we do with that? And then there's, of course, the live data from sensors, the GNSS, which Radoslav also mentioned, ETOT, and this is all coming up, and even the data producers are trying to pick up with those new evolutions. On the other hand, there are all kinds of European initiatives like Time Machine Europe, which is a European project, and where lots of national initiatives are also part of it, even also in Belgium. But this was about big data of the past for the future of Europe. So this is also what we are talking about when we are talking about e-archiving of location data. There are also projects about opening up the GNSS or the positioning data. So there are a lot of initiatives that could be tied together with this e-archiving initiative of program. What I think is what should be really necessary is that we need to collaborate, sharing infrastructure services nationally or even internationally, especially internationally using the same standards. But the collaboration of mapping agencies, cadastre, archives, academics, but also ministries that provide digital services. It depends on the country how that is organized, but this is an important factor. But what I also noticed is that there are loads of data that is hidden in living scanned archives or almost scanned archives. I can give you a brief example of toponyms that are, which means that those are place names or names of areas in Belgium, for example, that are inventoried over the past 200 years very systematically. This is not known by anybody, but on the other hand, there is a big demand for this type of data. So other parts, like researchers, they try to build it by using artificial intelligence or other techniques to reconstruct the data that is already somewhere, but not findable, in fact. So this is so there's loads of data that is hyper important for modern research using linked data or whatever, for the development of knowledge graphs, but this is still not findable. So this is another important aspect that we should take into account. And then we are still, what I received from colleagues from archives from Europe, from map producing agencies, that are still old habits. People want to have the data, like having the old map, but there should be some kind of transfer of mind, or in fact a mind shift, that we are not talking about paper anymore, but that we are talking about data, and that data is fluid, and that we should be able to take copies of it, maybe to preserve it on a tape, but also to keep it as a part of today's infrastructure. For example, that the location data, also the old location data, is served by today's producers or mapping agencies. Otherwise, it will become rather hard to reuse all the data, to find all the data. So there are still lots of question marks within the organizations, within the archives, or within the producer side, because there is still a limited mutual understanding. I wouldn't say there's a cat and dog problem, because I think there's a lot of willingness to collaborate, but we have to somehow trigger a mind shift. So where to start? Both sides. I think the eArch initiative is a wonderful initiative that allows all parties to start and work hands-on for archiving modern data, but we need guidance for that. And I think to already answer the question that you are going to pose me, Gregor, I think it is very important that we will make the decision already in production process. What are we going to archive? How are we going to archive? Because at the moment of designing the process, but also to design the product, the production of the product, that's the moment where the metadata can be generated. Afterwards, there's no time for it, or the person is retired, ill, dissatisfied, or whatever. We have a big gap in the 80s of digital tapes that were lost. They couldn't be read anymore, so a lot of data has already disappeared. So it's not too late to change our behavior. It's too late for maybe the 80s, but it's not today for today. It's not too late for today, so we should start change now. That is the message that I would like to give.
Well, thank you very much. It's very, very informative. And I see that these are also some of the topics that you mentioned during or asked during the presentations yesterday, especially the collaboration part, because I think that we still are working in a very siloed manner, archive separate and geospatial and mapping agencies separate. I know that in Slovenia we have the government GeoCloud, which isn't fully, let's say, operational or hasn't developed its own capacity. And then there's the geodetic and mapping agency that has its own e-space clouds, and it's like two silos that need to talk to each other. And if we want to bring the cost of preservation down, we need to start abandoning old practices of our own gardens that nobody can touch and so on, and make things interoperable. So it's a mind shift, of course.
Yeah, yeah, exactly. I can only confirm what you have just said, Gregor. I'm sorry that I just pushed in another image. I also showed it in 2019, but this is to demonstrate only an aspect of location, because we are talking now today about the archiving of location data, but it is also an instrument to open up data, especially multilingual data, but also to see the relationships between all kinds of processes and time developments, evolutions over time. This is just a website. There are other types of websites that also use the map to find old documents. In this case, it's about old maps, but you can apply it to paintings, to pictures, to text, to cadastre information, whatever. This is also an important aspect that we should take into account in the opening up of the archives. Thank you.
If I may join in and continue this discussion, I would just like to underline what Rink has said earlier on, and that is the need to add metadata at the point of creation. So from the point of view of archival science, this is really an important issue today, because everything that is later than that is basically too late. In my view, we should be working more towards the interoperability of solutions, and I think that we are aiming at the interdisciplinary work in development of a future solution. So these aspects somehow, in my opinion, will need to find their places in any policy that we might offer or build together.
Okay. Thank you. Is there anyone else from the panelists who would like to comment based on what we said?
I don't know if we are running out of time. I don't want to be too arrogant. I'm a part of the panel, but maybe I don't see that many contributions in the chat. But or maybe there are, but I think I've
yes, there are.
No, okay, I've missed it. Sorry. So I don't know if we have time for some very small remarks from the public, the audience.
Yes, we have a remark from Hari Bavona, who would like to answer, who would like us to comment on the perspective about the statement that the management of digital archives is cheaper than the non-digital analog archives. And I'm not really sure who stated this, but I believe that it depends. Definitely, if you have a digital records, you need less space than if you have analog records, and you have different problems. However, this doesn't mean that it is cheaper in the long run. But on the other hand, I believe that a lot of processes that are manual in the physical, let's say analog materials, can be automated to be run by machines and computers. So it's the work that you actually don't see, but to support this work costs money, because supporting machines with antivirus systems support and so on also costs money, and I think this is something that would show in time if this is cheaper or more expensive. Then we have a question from Jaana Pinnick, asking about, could we achieve a preservation by design in our systems like we aim to do with the GPR for privacy? So any comments on that?
Yeah, I've seen it. I don't know who wants to answer on it. I think a lot of location data is not GDPR sensitive data, especially what the mapping agencies collect. Cadastral agencies may be different. Maybe Anna Frederik would like to address that, or someone else. I'm sorry to. I don't want to shut anyone's mouth. But
I would like to comment.
Yeah.
Yeah, this idea about preservation by design, that is definitely what we think about too at the Danish National Archive, and what the ideas that we have is to discuss with the public administration using standards and using the digital infrastructure of Denmark. How can the archive process be a more integrated part of this infrastructure, this digital infrastructure, and use of standards and architecture already in use out there? So how can it be easier to archive later on? So we have these ideas. We just don't have the answers yet, but we are actually talking to people in the public administration and creating a reference group where we can discuss this matter and how to do it.
And then you might also speak about ethics, because we of course have to avoid that insurance companies or Belarusian autocrats will dig into in your past family history and say, okay, you have freedom of speech activist in your past, so you are highly probable to be an annoying factor, so you'll already go to prison or whatever, of the Chinese experience. But this is also an ethic issue, I guess.
Yeah, the privacy aspect of it, but I don't think that Jaana means it's that the privacy is part of preservation by design. It's just the idea that we think archiving in when we design the system, as we think privacy and security into the system when we design them. I think that's the idea that we, and as Gregor just asked me before, could we think archiving in when we produce these records instead of 30 years later? So it's that idea, I think, and we're working on that in the Danish National Archive.
We have a hand up from Martin Retorik from Czechia, and his question is there a chance for the archives to restore huge and sophisticated GIS in an automatic way? And my question to that, since I was talking about the preservation of GIS, is that not in its full form, but based on the standardized storage of certain elements, let's say structure of GIS and rendering, we can at least set up a system in a way that we can produce certain information product, but to actually create the full GIS system and automatically restore it would actually require us to do mapping of all the functionality and mathematics behind it and so on. So I think that we need to appraise what elements of GIS are needed to be stored like that. Then we have a hand from Mr. Radovan for a long time. So
no, I raised hand once and then again, but I would like to stress again that there are now two sides here. One is the producer and the other is the archive. And on the side of producers, there is a huge difference regarding the history, the times past, because we have so many big producers like state agencies and ministries. And I think we have to provide some kind of societal agreement between the archives and the producers which are in public hands. So archiving seems to be a technical problem, but it is not. Of course it is, but the things we are talking about are, let's say, known in geodesy before, but like standards and so on. But we have to decide what and how to archive and who will bear the costs, because the costs on the producer side for archiving purposes have grown enormously, will grow. We have to decide who will cover the costs, not only the costs of archive itself, the institution itself, but also of the work that has to be done in order to provide metadata and data for the archive from the side of the public institutions. So if we want to solve this problem, we have to introduce costs of archiving into the project costs of production also. That was not the case before, I think. I'm not archivist, but I feel that when we were dealing only with paper or materials, then we did not have encountered this problem. But nowadays, you are talking about standards. I'm talking about simplification. But this is a technical question. Which bears costs? So I'm finished. Thank you.
Yeah, I need to thank all the panel speakers and tell everyone that we have outused our time. So we are, I think, almost half an hour over our dedicated time, and we need to conclude our session. If there is any other questions, please just put them in the chat. We'll do our best to follow up on it and post a Q&A session document with the slides and the video recordings somewhere in the upcoming days or weeks. And I can really thank all the panelists for their contributions. You gave us a lot of thinking points and talking points for our next projects and next development of this, and also gave us a lot of reasons to create another conference like this and other types of networking opportunities, because we see that we need to talk about it. There are issues that need to be resolved, and that's why we need to work on it more and more. So again, thank every panel speaker who was willing to contribute and everyone who asked questions.
Pleasure.
And now I would like to ask Adelina to conclude the conference.
Yes, hello.
Okay.
Do you see me?
No.
We
No.
see an empty office.
Yeah, that's not what I wanted. So I don't know how I did that. Second. Is that better now? Okay.
Yes, we can
So,
see you now.
good morning or good afternoon, depending on the timing, from sunny Luxembourg. For those who do not know me, I'm Adelina Dinu, and I'm working in DG Connect as co-business owner for eArchiving building block, together with my colleague Fulgencio that you heard speaking yesterday in the introduction. I would like also to thank all the participants, speakers, and organizers for having dedicated the time to spend with us. During these 2 days conference, we've listened to inspiring presentations and exchanges. You shared with enthusiasm and interest to learn from each other best practices, challenges, experience, and solutions. Now, there are many takeaways from this conference. I will just name some of them. Preserving data in the long term is challenging, as you all know. And in order to best ensure the long-term preservation of data, of big data, of geospatial data in particular, we have to use international standards, interoperability, common specification, and all that is in eArchiving. As one participant mentioned in the chat yesterday, we need to preserve geodata for their value as a business asset and in certain cases for their legal and evidential value. While today we learned without a big surprise that the finding of a UK research is that preservation of geospatial data requires permanent retention. Different use cases and domains in which geodata preservation proves to be crucial were presented. Some of them are the building information modeling, business intelligence, transportation security, and I could go on with the list. We have also heard experiences from different European countries. We approached geospatial specifications and discussed about the impact of new technologies like AI or machine learning in the geospatial industry and on preservation and reuse. And in this sense, it was mentioned the importance of new skills, even more in the context of the digital decade. We saw how geospatial data can help in decision-making processes and how they can support a digital economy. In your interventions, there are many keywords that I would like to remind some of them that came different steps. Open source tools, format validators, accessibility, and also speed of accessibility, reuse, trust, authenticity, MicroStrategy geospatial services, predictive analytics, user engagement, and so on. What's of utmost importance is to add a preservation step to the data lifecycle and also to have a governance backing preservation. Moreover, having a digital preservation plan is a big step ahead. We at the European Commission, in fact, we support the uptake of digital services and of the eArch specification across a broad range of sectors and countries. I really hoped that you found also informative this event. Please do not hesitate to ask for information if you think we can be of help to you. Follow us on social media using the hashtag eArchiving, fill in the survey, stay in contact with us, and follow us in our next events, workshops. Thanks again. Have a nice afternoon. I don't know if Gregor, you would like to say something else, or
Yes, thank you.
Thanks.
So I can also say that I'm very happy that we came together in such large numbers. We were a bit skeptical because we started a bit late with this preparation due to the COVID changes and other tasks. And I see that this gives us more support for creating similar events and solutions in the future. And I thank all the speakers, all the support staff, Fulgencio, Pavel, Tom, Adelina, and the staff from eArchiving building block that helped us prepare this, who are not here today maybe, but we'll probably see this in the recordings. And to all the people who actually contributed and asked questions, because they are those who make this conference valuable. So thanks everyone for your contribution, and we hope to see you soon. Maybe next year or in 2 years, we'll see how things develop, but definitely we will create the next conference. Thank you.
Indeed. Thanks again.